These are sounds of our times. Called telemetry, it is the way satellites orbiting in space report to controllers on Earth. Each spacecraft has its own signature, a unique tone. Engineers call it data. You may see it later as a weather report or a television picture from around the world. Space down to Earth with application satellites. What they are, what they're doing for you now, and what will be happening in the decade of the 70s. Weather, communications, Earth resources. These will be among the main topics for dialogue in the 1970s. Each has its own type of impact on our lifestyles. At times, we will be more concerned about one than the other, but always they will be there. Case in point, weather. Spacecraft, like Tyros, Nimbus, and the application technology satellites. Satellites that return daily weather information over the entire world. What do they report? A continuous watch of the Earth's moving cloud cover, tracking storms, measuring winds, recording temperatures at different heights, and testing the moisture content of the atmosphere. As a result, computer systems are built that can receive and analyze vast amounts of global information from many sources, making forecasting more accurate. Hurricanes with their devastating winds and flood-causing rains, a perennial threat. In 1969, Hurricane Camille was first observed and then tracked by satellite. Because the storm's arrival was predicted accurately enough in advance, it was possible to evacuate people from the Gulf Coast. Without this early warning, the Weather Bureau estimated that 50,000 people might have been killed. In contrast, during Hurricane Laurie in November 1969, observations and tracking by satellite enabled the weather forecasters to predict that Laurie would not strike the coast. It is estimated that $3 million was saved from this satellite-prompted decision not to evacuate and not to protect property. Tyros, television infrared operational satellite. Over the past 10 years, 20 of these hat-box-shaped satellites have been successfully launched for use by NASA and the Weather Bureau. The television eyes of Tyros scan the entire globe daily, reporting on cloud cover and warning of major storms. Since the first operational weather satellites started clicking off pictures, roughly 600 severe storms have been detected, followed, and predictions made about their course. They have sent back more than 1 million pictures of weather conditions around the globe. Cameras on board the Applications Technology satellite scan the Earth and return color images as often as every 20 minutes. Here's a view showing 6 hurricanes on one picture. This near-continuous surveillance of 40% of the Earth's surface has proven so useful that the reports have been incorporated into routine weather forecasts and have pointed the way for even more sophisticated meteorological satellites. Major airlines make use of satellite data in planning their flights. Pilots routinely receive weather photos of their transoceanic routes. Before satellite tracking of hurricanes, U.S. Navy hurricane hunters had to search out the killer storms. Weather satellites now locate the storms, and the Navy flies directly to them to make their measurements. The Navy also uses weather satellite pictures for ice patrols. Remote stations in the Antarctic benefit too. giant resupply ski planes can be safely scheduled for landings in the icy outposts without worrying about being trapped by snowstorms. Supply ships benefit from improved scheduling as well. A recent satellite in the Tyro series does the work of 2 spacecraft. Carrying twice as many cameras, it's capable of discerning cloud formations as small as 2 miles across. The improved Tyros operational satellite carries a proton monitoring instrument that helps spot solar flares. The same instrument can measure the amount of heat reflected from and absorbed by the Earth's atmosphere. This is very important in weather forecasting. In addition, radio frequencies affected by solar storms can be changed in advance, and manned flights to the moon better planned. Nimbus, research and development craft studying advanced techniques and concepts for meteorological Earth observations. Nimbus is measuring the atmosphere's temperature and moisture at various altitudes, as well as making day and nighttime cloud photographs. These measurements are considered the key to accurate long-range weather forecasts. By the end of this decade, forecasts made 1 week in advance will be as accurate as those now made 24 or 48 hours ahead. Satellites and weather are global in nature. Every nation in the world can benefit from the automatic picture transmissions of U.S. weather satellites. Over 50 countries are now using inexpensive automatic picture readout equipment to view daily weather patterns over their own territory. These same countries also benefit from cloud picture mosaics, routinely made available by the Weather Bureau to Europe, Asia, Australia, and North and South America. The weather mosaic is built up from individual weather photos and processed by computer. It is then retransmitted by a satellite. There are 3 main objectives for an effective meteorological program. The first, global cloud cover photography, enabling us to identify and track storms and to observe their formation and dissipation. This is valuable in the analysis of current weather and the prediction of 24 to 36-hour changes. The second objective, continuous viewing of the atmosphere, needed to keep significant portions of the Earth's cloud cover under constant surveillance and providing essential early warning on rapidly developing weather phenomena, such as thunderstorms and the formation, growth, and death of tornadoes. This information is valuable for short-period forecasts of less than 12 hours. The third objective, a global atmospheric research program. Its goal, long-range weather prediction on a worldwide basis. In 1976, scientists from governments, industries, and universities in many countries will meet to work out the problems of international weather forecasting. The Global Research Program will use computers to design and test theoretical models